Hi friends, welcome to Let's Learn Civil Engineering Classroom. This video contains the numerically solved questions taken from previous year question papers of Kerala PSC in Civil Engineering, especially Kerala Water Authority. Before I start, I request my viewers to subscribe my channel and click the bell button for further notification. The first question, the volume of cement contained by one bag is. Let's see how we can solve this problem. We know that one bag of cement is equal to 50 kg and the density of the cement is 1440 kg per meter cube, which means 1 meter cube of cement weighs about 1440 kg. So density is equal to mass by volume. Hence, if we substitute these values in this equation, 1440 is equal to 50 kg divided by the volume. So volume is equal to 50 divided by 1440, which is equal to 0.0347 meter cube. So the answer is the volume of cement contained by one bag is 0.035 meter cube. Next question. If two forces 3 kg and 4 kg acts at right angle to each other, their resultant force will be equal to. Let's draw a figure. A horizontal force 4 kg and another force which is acting at right angle to it, that is 3 kg. Then its resultant will be R. Now, by the law of parallelogram, let us consider a triangle here. One side is 4 kg and the other side is 3 kg. The resultant R can be found, the length of R can be found by R is equal to root of 4 square plus 3 square. That is, we apply here the Pythagoras theorem. R is equal to root of 4 square plus 3 square, that is equal to root of 16 plus 9, which is equal to root 25, that is 5 kg. So the answer, if two forces 3 kg and 4 kg acts at right angle to each other, their resultant force will be equal to 5 kg. Next question. If the bearing of a line AB is north 40 degree west, the bearing of another line BC is north 20 degree east, then the angle B is equal to. So now let's see the solution. Given the bearing of AB is north 40 degree west, which means the north 40 degree west means it is in the fourth quadrant. Hence we draw here a meridian, a magnetic meridian, and we draw a line AB which is in the fourth quadrant. So the fourth quadrant can be identified by the reduced bearing is given as northwest. Northwest means it is in the fourth quadrant, and given the angle is 40 degree. 40 degree means in reduced bearing the angle is measured from north or south, whichever is nearer. Hence the line is more nearer to north. Hence this angle is 40 degree. So if we convert this angle, this reduced bearing, into whole circle bearing, that is angle taken from the magnetic meridian or the magnetic north in clockwise direction only. So in clockwise direction this angle is the whole circle bearing. Hence the whole circle bearing of this line can be found by 360 degree minus this angle, that is 40 degree. So which is equal to 320 degree. So this line is AB. So now let's see the second part of the question, that is the bearing of BC is given as north 20 degree east. So we know that the bearing of BC means it is the forebearing of BC. Hence the line start at B and end at C. So this is the line BC. So if we see that the bearing of BC is given as north 20 degree east. The northeast is in the first quadrant, hence we draw a line in the first quadrant. So this angle is given as 20 degree, As we know that in the first quadrant the reduced bearing is equal to the whole circle bearing, hence the whole circle bearing of the line BC is equal to 20 degree. Now in the question we need to find the angle B. Angle B means this included angle B. So this included angle B can only be found by subtracting this smaller angle from this angle. That is, if we take or if we subtract the bearing of BC from the back bearing of AB, we get the included angle B. So for angle B is equal to back bearing of AB minus the forebearing of BC, that is this angle minus this smaller angle. So the back bearing of AB can be found out by, as we know that the forebearing of AB is 320 degree, hence the back bearing is minus 180 degree. So 320 minus 180 minus the forebearing of BC, that is 20 degree, which is equal to 120 degree. Hence the answer for this question is option D, 120 degree. Now let's see the fourth question. If whole circle bearing of a line is given, that is 120 degree, how can we change it into the reduced bearing? So if a line is 120 degree and it is given that it is the whole circle bearing, and first of all we need to understand what is whole circle bearing. Whole circle bearing means it is an angle which is measured from the magnetic north in clockwise direction. Hence, if we take this angle 120 degree, we can draw a line like this. So this angle is 120 degree, which is greater than 90 degree and less than 180 degree. So this angle is the whole circle bearing, 120 degree. So if we need to convert it into reduced bearing, we need to know what is reduced bearing. Reduced bearing is an angle which is measured from north or south, whichever is nearer to the line. So we know that the line is in the second quadrant, hence the line is more nearer to south than the north. So the reduced bearing is measured from the south. In this case it is measured from the south in anti-clockwise direction towards the line. So this angle is the reduced bearing angle. So this angle can be found by subtracting 120 degree from 180 degree. The reduced bearing of the line is equal to 180 degree minus the whole circle bearing, that is 180 degree minus 120 degree, which is equal to 60 degree. So as we know that the line is in the second quadrant, the quadrant south and east, so it is designated as south 60 degree east. So the option B is the right answer. Now let's see the next question. The magnetic bearing of a line is given as 32 degree and magnetic declination is given as 10 degree 15 minutes west. What is the true bearing of the line? So before solving this question, first of all we need to understand what is a magnetic declination. A magnetic declination is the horizontal angle between a true meridian and a magnetic meridian. So given that the magnetic bearing of the line is 32 degree, so it is the whole circle bearing of the line. The declination is given as 10 degree 15 minutes west. So let's draw a figure. So this line indicates the true meridian, and another line, another meridian we are drawing here is the magnetic meridian. Since I draw this magnetic meridian to the left side of the true meridian because it is given as the declination west. When it comes the declination west, the magnetic meridian will always lie on the left side of the true meridian. If this is declination east, the magnetic meridian will lie on the right side of the true meridian. So for this question, the declination is west, hence the magnetic meridian is on the left side of the true meridian. Okay, now it is given that the declination is 10 degree 15 minutes. So 10 degree 15 minutes means the horizontal angle between the true meridian and the magnetic meridian. So this angle is the declination angle. Given the magnetic bearing of a line is 32 degree. So magnetic bearing is taken with respect to magnetic meridian. Hence, if we draw a line here, so this angle is 32 degree. Okay, we need to find the true bearing of the line. True bearing means this angle. So if this angle is 32 degree and this angle, that is the angle between true meridian and magnetic meridian, is 10 degree 15 minutes, we can find the true bearing is equal to the magnetic bearing minus the declination. So this is equal to, the magnetic bearing is 32 degree and the declination is 10 degree 15 minutes. This is equal to 21 degree 45 minutes. Hence the answer is option C, 21 degree 45 minutes. Next question, if sin theta is equal to 3 by 5, then what will be cos theta? So this is a simple problem. Let's consider a triangle, a right angled triangle, and here we consider an angle theta. We know that sin theta is equal to the opposite side by the hypotenuse. So here the opposite side is 3 units and the hypotenuse is 5 units. So since this is a right angled triangle, we can find the third side by applying Pythagoras theorem, that is the adjacent side, that is the adjacent side to this angle theta. The adjacent side is equal to, by applying Pythagoras theorem, it is equal to root of 5 square minus 3 square, hypotenuse square minus the opposite side square. So which is equal to root of 25 minus 9, that is equal to 16, which is equal to 4. So we get that this line, this adjacent line is 4. So for cos theta, we know that the equation for cos theta is the adjacent side by hypotenuse. Now the adjacent side is 4 and hypotenuse is 5. Therefore cos theta is equal to 4 by 5. So on looking these options, there is no such option, that is 4 by 5. Hence the answer is none of these options. Next question. Find the value of declination if the magnetic bearing of the sun at noon is 184 degree. Here also, this is a problem of declination. We know that when the sun is at noon, the true bearing will be 180 degree. So let's consider this as a true meridian. If the sun will be at noon, then the true bearing will be 180 degree. That means the sun will be at the south of the true meridian. So here is now the sun at noon. Given the magnetic bearing of the sun is 184 degree, which means the magnetic bearing lies on the left side of the true meridian. Okay, so now let's draw a magnetic meridian which is on the left side of the true meridian. So only if the magnetic meridian is on the left side, we can take this angle as 184 degree. So we can easily find this angle, that is the declination. The declination is found by subtracting the bearing, the true bearing of the sun from the magnetic bearing. Therefore the declination is equal to magnetic bearing minus true bearing. This is equal to 184 degree minus 180 degree, which is equal to 4 degree. And since the magnetic meridian is on the left side of the true meridian, it will be declination west. So the answer is 4 degree west. Next question, which comes from the topic irrigation. A crop requires a total depth of 92 centimeter of water for a base period of 120 days. What is the duty of water? Given the depth of water is equal to 92 centimeter, that is 0.92 meter, which is represented by the letter delta. and also given the base period is equal to 120 days, we need to find the duty of water. So we have a relation connecting the duty, delta and the base period. That is, by the formula, delta is equal to 8.64 into B by D. 8.64 into base period divided by the duty. So from this formula we can find the equation for duty, that is duty D is equal to 8.64 B by delta. So on substituting these values, that is 8.64 into base period is 120 days and delta is 0.92, the answer is 1126.9 hectares per cubic. So the answer is option A, 1127 hectares per cubic. Next question, a 9 kilometer is represented by 1.8 centimeter. So what is the scale? So this is a simple problem. For a length of 9 kilometer, it is represented in the sheet by 1.8 centimeter. As we know that given 9 kilometer is equal to 1.8 centimeter in the sheet, that is, a scale is represented by map distance divided by the ground distance. So we can see that the 1.8 centimeter is represented on the sheet and 9 kilometer is measured on the ground. Hence the map distance is 1.8 centimeter and the ground distance is 9 kilometer. Let's convert this into the same units, that is 1.8 centimeter divided by 9 lakh centimeter. So on cutting numerator and denominator, which is equal to 1 divided by 5 lakh, that is 1:5 lakh. So the scale represented for 9 kilometer to 1.8 centimeter, the scale is 1:5 lakh. The next question, the reduced bearing of a line is north 87 degree west. What is its whole circle bearing? As we know that for a reduced bearing is measured from north west. The line is northwest. Hence this line lies on the fourth quadrant. Okay. So we draw a magnetic meridian and a line on the fourth quadrant. So given that this angle is 87 degree, if we need to convert this into whole circle bearing, this angle is the whole circle bearing. So for whole circle bearing is equal to 360 degree minus this smaller angle, that is 360 minus 87 degree, which is equal to 273 degree. So the answer is option B, 273 degree. Next question. For 1 cubic meter 1:2:4 concrete using 20 mm metal, the quantity of coarse aggregate required is. So for this problem we need to know the density of the concrete. Given the volume of the concrete is equal to 1 meter cube, assume a wastage of 20% and a bulking of the sand about 35%, that we need to add a 55% extra to the volume of the concrete, since the concrete is in the wet condition, and if we take the material in the dry condition, there will be, when adding water, there will be bulking of sand and there will be a wastage of 20%. Hence we add a 55% extra. So the total volume will be equal to 1 plus 0.55 into 1, that is 55% of 1 meter cube, which is equal to 1.55 meter cube. So this is the total quantity of concrete for which we need to find the quantity of the coarse aggregate. So given the mix ratio is 1:2:4, hence the volume of the cement required, we need to find the volume of the coarse aggregate. First of all, we are going to find the volume of the cement. The volume of the cement is finding out by the total volume, that is 1.55, divided by adding the ratio, that is 1 plus 2 plus 4, that is 7, 1.55 divided by 7 is equal to 0.221 meter cube. So out of these 1.55 meter cube, 0.221 meter cube will be cement. So for coarse aggregate, we know that the ratio indicates 1:2:4 means 1 part of cement, 2 part of fine aggregate and 4 part of coarse aggregate. Hence, if we find the volume of the cement, the volume of or the quantity of the coarse aggregate will be 4 times as that of the cement. So volume of the coarse aggregate is equal to 0.221 into 4 times, which is equal to 0.885 meter cube. So the answer is, for in the given option, the answer is 0.9 meter cube, which means that is 0.885 is approximately equal to 0.9 meter cube. Next question, the slant height of a right circular cone of base dias 6 cm and height 4 cm is. So let's see the solution. Let's draw the figure of a right circular cone. So a right circular cone having a height of h and the radius, the base radius is r. This dimension, the slant dimension that we need to find. So for slant dimension, just apply the Pythagoras theorem. So for a Pythagoras theorem, this is a right triangle and this is the hypotenuse, this is one side and this is the another side. So if we need to find the length of this slant space, if we need to find the slant height, L is equal to, by applying Pythagoras theorem, root of h square plus r square, that is equal to root of h is given as the height of the right circular cone is 4 cm and diameter is 6 cm, hence the radius is 3 cm. So root of 4 square plus 3 square, which is equal to root of 25, that is L is equal to 5 cm. So the answer is option A, that is 5 cm. Next question. A concrete dam of rectangular section has a water standing to a height of 12 meter from its base. The distance of the pressure acting from the base of the dam is. So for this question, we know that at every section, the pressure intensity or the resultant pressure is act at 1/3 from the base. Okay. Always the pressure, the resultant pressure, act at 1/3 from the base, act at a height of 1/3 from the base. So the resultant pressure acting on the dam is at 1/3 of its height. So given that the height of the dam is 12 meter, so 1/3 of 12 is equal to 4 meter. So the answer is option A, 4 meter. So next is the next question. The height of water column equivalent to a pressure of 2 kg per centimeter square is. We know that 1 kg per meter square will be equal to 1 mm height of water column. So here the unit is kilogram per centimeter square. We know that 1 kg per meter square is equal to 1 mm height of water column. So just we convert this meter square into centimeter square. This will be equal to 1 divided by 10,000 kilogram per centimeter square. That will be equal to 1 mm height of water column. So 1 kilogram per centimeter square will be equal to 10,000 mm height of water column. That is 1 kilogram per centimeter square is equal to 1000 centimeter. We just convert this mm into centimeter. That is 1000 centimeter height of water column. So 1 kilogram per centimeter square is 1000 centimeter. Therefore 2 kilogram per centimeter square will be equal to 2000 centimeter height of water column. So the answer is option C, 2000 centimeter. Next question. From a leveling field book, the intermediate side is given as 1.5 meter and its reduced level is 100.5 meter. What is the height of instrument? So let's see the solution. We just draw a figure. That is, this is the instrument, a dumpy level. This line represents the height of the instrument from the datum. So we fix a leveling staff at a point which is having a reduced level of 100.5. So given that the reduced level is 100.5, and we take an intermediate side to that point, that is 1.5. So intermediate side means that this height is 1.5 meter. So for height of instrument, we know that the reduced level of the point 100.5 is given from the datum. That is, the height from the datum to this point is given as 100.5. So if we need to find the reduced level of height of the instrument, that is, the height of the instrument from the datum, height of the instrument is equal to reduced level of this point plus the side towards the point, that is, which may be the intermediate side or foreside or backside. So the height of the instrument is equal to reduced level of this point plus the side towards the point, that is the intermediate side, which is equal to the reduced level of the point is 100.5 plus 1.5, that is side towards the point. So the answer will be 102 meter. So the answer in this option is option C, 102 meter.